Let's take a look at another functional equation, which is the problem 5 of the International Mathematical Olympiad 1994. It says, let S be the set of all real numbers strictly greater than -1, and find all functions f from set S to set S itself that satisfy the following two conditions. The first one is f evaluated at x plus f of y plus x times f of y equals y plus f of x plus y times f of x for all x, y in set S. And the second one is f of x over x is a strictly increasing function on the intervals. -1 is less than x is less than 0, and also x is larger than 0. Okay, so let's see whether we can find some interesting property here. So the original function equation, let's call it p of xy like this. So let's plug in some value to see whether we can get something. Okay, so let's try to put in xy to be 0, which means we have a p of 0, 0. Okay, then we will have f of 0 plus f of 0 plus 0 times f of 0, and then equals 0 plus f of 0 plus 0 times f of 0. Okay, so we can quickly find that this is 0, this is 0, this is 0, this is also 0. Okay, then we can have f of 0 equals f of 0. Let's try to make it in red color, which means that we can say that f has a fixed point x of 0 equals f of 0, such that f of x of 0 equals x of 0. Then we call it a fixed point, which means that this f map the value to itself. Okay, so the next is that let's try to plug in this x of 0 into the original function equation, which means we plug p of x of 0 comma x of 0. Then we will have f evaluated at x of 0 plus f of x of 0 plus x of 0 times f of x of 0 equals x of 0 plus f of x of 0 plus x of 0 times f of x of 0. Okay, so there are many x of 0, but fortunately we have a interesting property is that f of x of 0 is x of 0, which means that we can change this one to x of 0, this one to x of 0, this one to x of 0, and also this one, which means that we can quickly find that f evaluated at 2x of 0 plus x of 0 square equals 2x of 0 plus x of 0 square, which means that x1 equals 2x of 0 plus x of 0 square is also a fixed point. Okay, as you can see here, let's try to put it in red color. So this is a fixed point. The f map this value to itself, map x1 to itself. Okay, so the next step, let us try to prove that f has a unique fixed point at x of 0 equals 0. It can't be any other else. Okay, so let's try to prove it by contradiction. So the first case is that, case number 1 is that if x of 0 is smaller than 0, and of course it is larger than -1 because for set S it is all real numbers strictly greater than -1. So here the case 1 is x of 0 is negative, but it should be larger than -1. Okay, so here, as if x of 0 is negative, then x1 equals 2x sub 0 plus x sub 0 square equals x sub 0 times 2 plus x sub 0, like this. It's also a fixed point, as we have shown it above. And we can observe that this one, we can observe that this one is a negative number. This is negative number, and x sub 0 is between -1 and 0, so that 2 plus x sub 0 should be a positive number. So when we have a negative number multiplied by a positive number, which means that this is smaller than 0. So if x sub 0 is smaller than 0, then x1 is also smaller than 0. Okay, so however, we have a condition like, so we can also write it as a f of 0 over x sub 0 equals f of x1 over x1 equals to 1, because it is a fixed point. So we can try to divide both sides by x sub 0 and x1, then we can get this equation. And for condition 2, we know that f of x over x is strictly increasing on each of the interval, so including -1 is less than x is less than 0. So here we make use of this condition. However, f of x over x is strictly increasing. Strictly increasing at -1 is less than x less than 0, which means that this is a negative number, this is a negative number. So x sub 0 should be equals to x1. Yeah, so here we know x sub 0 equals, we calling this one, it is 2x sub 0 plus x sub 0 square. So we can find that it is x sub 0 square plus x sub 0 equals 0, which implies that x sub 0 times x sub 0 plus 1 equals 0, which means x sub 0 equals 0 or -1. However, x sub 0 should be between -1 and 0, so it is a contradiction. So the first case, we have proved that x sub 0 can't be in this interval. So the second case is that if x sub 0 is larger than 0. Okay, so here we can also find that x1 equals 2x sub 0 plus x sub 0 square. So this time is larger than 0, this time is larger than 0. When we add them together, it must be larger than 0. Okay, so in this case, we can also write that f of x sub 0 over x sub 0 equals f of x1 over x1 and equals 1. And f of x over x is strictly increasing. At x is larger than 0, so that x sub 0 should be equals to x1. And using the similar argument, we can say that x sub 0 equals to x sub 0 plus x sub 0 square. So which implies that x sub 0 equals 0 or -1, which is also a contradiction because we assume that x sub 0 is a positive number. So this is a contradiction. So in that case, we prove by way of contradiction that f has a unique fixed point at x sub 0 equals 0. Okay, so the next step is from the original function equation, if we try to plug in p of x comma x, which means y equals x, then we will get f of x plus f of x plus x times f of x equals x plus f of x plus x times f of x. So now we may call g of x to be x plus f of x plus x times f of x. Then we will have f evaluate at g of x equals g of x for all x in set S. So which means that g of x is a fixed point for all value of x. And as much as we have shown, f has only a fixed point at x equals 0, which means that g of x must be 0 for all value of x in set S. So which means that x plus f of x plus x times f of x should be 0. And then we can quickly find that f of x equals negative x over 1 plus x. Okay, so let's try to check whether this solution satisfies the original function equation. So we check it. So the first condition is that the left-hand side equals f of x plus f of y plus x times f of y. Okay, so here we have f of x minus y over 1 plus y plus minus x times y over 1 plus y. Okay, so we can do some simplification. So actually this is like 1 plus y, and then we have a x plus xy. So we can do some cancellation, which is like this one can cancel with this one. And it turns out to be f of x minus y over 1 plus y. And then it is equal to negative x minus y over 1 plus y, and then we have 1 plus x minus y over 1 plus y. Okay, so this 1 can be written as 1 plus y over 1 plus y, so that we can also do some cancellation. This y can cancel with this y, and then this 1 plus y can cancel with this 1 plus y. So it turns out to be x minus y over 1 plus x. This is the left-hand side, and for the right-hand side, it is actually y plus f of x plus y times f of x. Okay, so let's try to plug in the solution. Y minus x over 1 plus x minus xy over 1 plus x. So this one will be y plus xy all over 1 plus x. Okay, so we can also do some cancellation. This one can cancel with this one. Okay, so finally here, actually I think I forgot this minus sign, so here it should be y minus x instead. So finally we get y minus x all over 1 plus x. So the first condition is okay. And for the second condition, as f of x equals negative x over 1 plus x. So f of x over x equals negative 1 over 1 plus x. So this function is strictly increasing. For the interval, negative 1 smaller than x is smaller than 0, and also x is larger than 0. Although for this function, actually it is strictly increasing for x is larger than negative 1, but if it does not give the condition like this, then we cannot come up with our solution. So yeah, so actually this solution is okay, and that's the end of this video.